Okay, welcome everybody to a test automation platform designed for the future. I'm Dave Piacente, DevRel here at Applitools, as well as the Director of Test Automation University. I'm joined today by Adam Carmi, a man that actually needs no introduction, but I'll give him one anyway. Adam, the co-founder and CTO of Applitools. He is the inventor of visual testing and a leader within our industry with over 20 years of experience pushing the boundaries of what people thought possible with the technology of today. He holds advanced degrees in computer science from Technion, and he's held management, research, and development positions at companies like SafeN, IBM, Microsoft, and Intel. Put another way, he's very smart and he's very good. So welcome, Adam.
Thank you, Dave. I'll start blushing. It sounds better than it is.
It sounds very good on paper. It's actually true. So let's get into it. I just wanted to start before you actually get into your presentation and just share why I'm super excited about what's going on at Applitools and what we're doing here to talk about today. If we go way back in time and we go back to about 10 years ago, an unseasonably hot day in the September in Bangalore, India, I was attending Selenium Conf. I had just helped organize the conference. It was a very overwhelming experience being there in person and just seeing all the excitement and energy there. And in the crowd next to me was this very tall man who tapped me on the shoulder. His name was Moshe Milman. He had this company that I'd never heard of called Applitools. And he was talking to me about this whole thing, visual testing. And I was like, I have no idea what this is. From there, fast forward to having a conversation with you and you sharing basically the vision of everything you're doing, this presentation that you had about the things you were building. And I was like, this is amazing. And from then I started doing contract writing, became an advisor for the company. And then fast forward a few more years, I thought, man, it'd be amazing if I can help actually build the products and that you guys are building. I think they're very impressive. And so I joined R&D. I worked as an engineer for 5 years. Fast forward to now, I'm doing DevRel and community. And I can't think of a more interesting and exciting place than to be right here, right now, as we celebrate this milestone in what we're building and how it's just one step on the journey that we're taking because there's much more to come. So I just wanted to share that I thought this is amazing. So I'm very excited.
Just following up on where you started, since Applitools was founded 10 years ago, we have been hard at work applying cutting-edge AI to push the boundaries of software testing. And it all started with the invention of visual AI, the revolutionary computer vision technology that created an entirely new testing category that is known today as visual testing, of course. Then we went on and invented the ultra-fast grid, which can execute end-to-end tests across any device, browser, and operating systems in order of magnitude faster, more stable, and more secure than with any other test infrastructure. And just 6 months ago, we completed the acquisition of Preflight, an innovative record and playback test automation tool, and also launched the Execution Cloud that can execute open source based tests at a massive scale while seamlessly applying AI to automatically heal broken element locators that would otherwise lead to crashes. So as you realize, we have been very busy in the past few years building cutting-edge test automation platform while continue to evolve and perfect visual AI technology that we started out with. And I'm very happy to share with you that yesterday, Applitools took yet another significant step forward and launched the world's first fully autonomous testing product for websites and multi-page web application. This product is a result of years of dedicated development, and I'm super proud of the Applitools team for this achievement, and I'm beyond excited to present it to you today. So, no more hand-waving and promises for the future. This is the moment to see real autonomous testing in action. And we actually have quite a lot to cover. We'll start by discussing why is autonomous testing even needed. Autonomous testing sounds like science fiction, right? But it isn't. And we'll spend some time discussing the realistic goals of autonomous testing. And I also show you how it can be achieved. Then we will spend some time talking about the Applitools intelligent testing platform and highlight some of its main capabilities. And finally, we'll look at autonomous, see it in action, and just see how autonomous testing is done. Of course, there will be time at the end to answer any question that you may have, and feel free to ask them also as you are watching the session, and they will be answered later on. So why autonomous testing? To answer that, let's take a look at the test automation lifecycle. I'm sure that many of you are experienced testers and you know just how much work is required to set up and maintain a test automation project. So many people, so many skills required. We need architects, DevOps engineers, and developers to build a proper test automation framework. We need to integrate it with the CI and CD pipeline so they will execute when new builds are published. We need to choose a lab provider or build a lab of devices and browsers in-house to run our tests on. Then we need to spend a lot of time creating tests for all those features in the product. And whenever there are changes to the product, we need to adjust and adapt the existing tests to those changes. We need someone with a quality mindset, preferably a quality lead that is able to judge the tests that we have and verify that they provide us with adequate coverage. We then need to take all those tests and execute them at scale across different devices and browsers. And we have to make sure that the tests run fast enough, not to reduce the velocity of the dev team. And they have to be stable enough so we don't have to rerun them and be frustrated with failed builds. And just doing this part takes a huge amount of continuous effort and massaging of the framework for the entire lifetime of the project. And once we get those test results, in many cases, not all tests have passed. And it definitely doesn't mean that each test that failed means that we found a bug in the product. In many cases, these are broken tests due to flakiness or just because the UI changed and we need to update those tests. So we need to spend time triaging the problem. We usually need the developers that wrote the test to do that work. We need to figure out if it's a real bug, if it's a problem in the infrastructure, it's a problem in the network, a problem in the test itself. We need to fix everything, rerun everything, hopefully everything will run again, and we need to repeat this process again and again and again every time we have new features or new code is pushed to source control. Okay, so a lot of work. And what makes this process even more cumbersome is the fact that the traditional approach to automation, the way that we have been automating for the past 2 decades or more, is far from being perfect. It has a lot of limitations and disadvantages. So to illustrate that, let's consider a very common requirement. We want to make sure that if a user tries to log in to our application and he doesn't provide his username and password, he sees error messages that indicate that those fields are required. And here is a Cypress test, an end-to-end test that actually tries to verify that this requirement is met. Cypress is at the forefront of test automation today, a very popular test automation framework that is very loved by developers, especially written in JavaScript, but the test would look just about the same in Selenium, in different programming language, in other frameworks for mobile applications as well. Very similar concept. So what is this test doing? In line 3, we are visiting the login page. In line 5 and 6, we locate the login button and click it. And then in lines 8 to 17, we have a bunch of assertion code that basically scans through the DOM, through the view hierarchy of the page, finding error elements, make sure that there are 2 of them and that they have the correct text. Now, there are 3 things that are immediately not optimal with this approach that we can see. First of all, we need an engineer or a practitioner that knows how to write code, probably a developer, that needs to write relatively a lot of code to test something so simple. Second, the level of coverage that we are getting out of this test is very, very small, and we'll see why later on. The third disadvantage is that this code, the way that it's written, is intimately tied to the way that the UI is implemented, meaning that when the UI will change, either because a front-end developer will decide to refactor it because he wants to change the code and make the implementation better, or because we have a feature request to add something or remove something from the page, it is very likely that this change will cause this test to fail. And when this test fails, which usually happens at the worst time, when I pushed some code, I want to get some feedback for it, and instead of getting feedback that everything's okay, all of a sudden I have a bunch of tests that fail and I need to go in and look what happened and fix them. When it fails, the same developers that are responsible to either develop the application itself under test or responsible for keeping up with test coverage and adding more tests need to stop what they're doing and start triaging the problem. And the way to do it, in many cases, is reading log files. And the only people that can do that work is the developers themselves, because they are the ones that are writing those log files. They are the only ones that can read them. And once they read the log files and they figure out that the test is broken, they need to find the guy that owns the test. He needs to go into the test and needs to figure out what went wrong, then go ahead and fix the test and rerun it. Hopefully it will run this time, etc. So what we see across the board, and it doesn't matter if you're a small startup or like a large enterprise, is that mature test automation teams at some point reach a state where they spend 40 to 70% of their time just analyzing failed test results and fixing broken tests. Every test that you add increases the amount of maintenance overhead that you have. Okay, and when you get to a point where 70% of the time you're just dealing with the existing test, you just don't have enough time left to add more tests and keep up with the changes in the application and the additional coverage that's needed. And when that happens, the value that you're starting to get out of your automation project start to diminish, because all this functionality that you cannot cover with automation anymore is either tested manually in the best case scenario, or it is just not tested in the worst case scenario. In any case, automation is not helping you as it should. Now, the sad truth is that even the tests that you do have in place don't give you really much coverage. That is because automation, the traditional approach to automation, is incapable of catching or detecting unexpected bugs, okay? The only way to do that is with exploratory manual testing. So let me give you some examples. Let's assume that we have a developer on the team that decides to change the CSS of the application for his own needs because it works well in another page that he's working on, and accidentally causing the sign-in button to change. You can see that it is green, it is shorter, the text is dark, it's not capitalized. This is what we would categorize as a visual bug. Why do we call it a visual bug? Because the button is still there. You can still click it. If you click it, it will sign in. It is working, but the page doesn't look visually the way that it's supposed to. Right now, we have a test that deals with this button, that deals with this flow. Someone spent the time to write this test, but still this test will pass because it just doesn't cover this aspect of the application. Now, we may argue, so for some teams, this would be a critical issue. For other teams, this would be a minor issue. But in any case, the test that we have won't catch it. Now, you may argue that this test is not intended to find a visual bug like that. But imagine that the same CSS change that we've done would actually cause the error messages to become white. Why? Because on another page, white error messages look great. But in this case, it's white. It's white error messages on a white background, meaning that the end user cannot see those error messages, right? So this is a functional bug now because we had the functional requirements to show error messages and we are not showing them. The end user cannot see them. However, the test that we have in place to catch that case still passes. Why? Because the error elements are still there and they still have the correct text. It's just that it happens to be that this is an unexpected way in which the functionality broke. The text is correct, right? And there could be an infinite number of other unexpected ways for the functionality to break. For example, maybe the error messages became too tiny to read. Maybe there's a deployment issue and different fonts were deployed, and although the text is correct, the fonts are incorrect on the screen as the user sees them. Maybe the error messages appear elsewhere on the page. Maybe they are partially hidden by another element. And there could be many, many other ways in which this functionality can break, and our tests that were written exactly for the purpose of catching them will not catch them. Okay, so the outcome is, and I'm sure that many of the more experienced practitioners in the audience are well aware of, is that most test automation projects fail, or at least fail to deliver on the full promise of automation. This is the reality, sad reality, unfortunately. Let's go back to autonomous testing and its goal. So is the goal of autonomous testing to basically eliminate us inefficient testers and developers and remove us from the testing process? The answer to that is absolutely no. Absolutely no. And actually, I can't see any scenario today or in the near future, at least with the current technology, that AI will replace any of us. First of all, it's not accurate enough to be trusted blindly. I cannot imagine a situation where a customer reaches out to us and tells us he found a bug, and we say, sorry, you're on the 2% of bugs that we don't check for. Okay, we are 98% accurate, which is very accurate for AI, right? We'll never do that. We need to always have the system working to the best that we can, and we need human intervention to make sure that that happens. Any AI system requires adjustment, it requires feedback. You need to tell it what to test, when to test it, to make sure that it does what it's supposed to do. If it doesn't do it, you need to tweak it to make it work. Anyway, you need people to operate the tool. A lot of quality issues are quite subjective. Every day I see developers arguing if the code changes they did are good enough or not. I see designers arguing with front-end developers of whether the spec looks good or whether the implementation the developer did complies to the spec. These are very subjective matters. There is no way ever that we are going to trust an AI to make better judgment where we cannot decide between ourselves, right? AI has a limited perspective. Let's say, for example, that the AI sees that an icon changed in the UI. It has no way of telling if it's a bug or not, right? Because maybe the icon looks great, the new icon looks great, but perhaps it's the wrong one. Perhaps it's the correct one, but it should only be deployed in 2 sprints from today, not today. So it's a bug, although it's the correct one. So AI will always won't have the same perspective that we as a team, as human beings building software have. Because of that, it won't be able to take over completely. And also, all the AI tools out there will have limited scope. So they will be specialized to solve and give us coverage in a certain area of our application. It won't give us 100%. So we will always be needed to fill in the gaps. And even if it does really a lot, it will just free up our time to test the sort of stuff that only human beings can do, okay, whether automatically or manually. And if we continue with this line of thought, we've all seen amazing demos of GitHub Copilot and ChatGPT generating beautiful code for a complete game and all of that. It's really amazing to see. And without doubt, generative AI has lowered the bar for producing software at scale. But what does this mean? It means that now you'll have many more developers that are far less skilled than what we are used to today, that can produce far more code that is generated by a mindless machine. So what impact do you think this will have on software quality? I don't know what you're thinking, but for me, it's clear. The impact will be huge and it will be negative. And we will need quality practitioners to help make sure that the quality is retained. And it means much more work for all of us. I think it's a very good news for all of us here attending this session. So what is the goal of autonomous testing really? It is to make automation at scale accessible effortlessly to all. This is the goal. This is what we want to get to, that everyone, every team will be able to do automation at scale. And to get there, what we need to do is, first of all, get to produce tools that attain near complete test coverage, okay? The best-in-class teams today, with a lot of effort and talent, maybe with their end-to-end test can get to 20% coverage, if they are very, very good. We're talking about getting to 80% plus coverage out of the box. We want tools that could catch a lot of expected defects without us having to explicitly tell them to do that. But more importantly, we want them to catch the unexpected defects, like we saw in the example before. We want to lower the required skill set to succeed with automation. Today, to succeed with automation at scale, you have to have developers on the team. It's a must. We want to get to a point where every team member that understands software quality can operate and maintain automation at scale. And we also need to drastically reduce the human involvement from where we are today, where everything is totally depends on the human involvement, to a place where humans are only needed to review findings and decide if there are bugs or not, and to fill coverage gaps, the places where the AI cannot reach. Okay? So these are very ambitious goals to get to, but I want to show you that this is definitely doable. It can be achieved. Conceptually, we can go back to our test from the beginning of the talk and imagine that this is something that a human being had to write. 100% of this had to be written. If we can make AI produce all this code by itself and we can eliminate this code from our test, then we got to autonomous testing, okay? And in order to do that, let's look at the different parts of the code in this test and their responsibilities. And all the tests have these parts in them. So the first type of test fragment deals with navigation, simply going to URL and visiting it. The second part is interaction. I'm typing some text in a form, I'm clicking a button, checking a checkbox, etc. The third part is validation. I'm actually validating that the output that the application produced is correct, okay? Finding expected bugs, finding unexpected bugs, etc. Now, navigation is easy to eliminate, right? We've had crawlers for maybe web crawlers for maybe 2 decades now. It's very easy. Google is doing it all the time. It's easy to go to a website and find all its pages. That's an easy one. AI can definitely do that. Interaction seems very tricky, but actually for several years now, there are various methods to accomplish that. We've seen smart crawlers that can crawl their way through forms, etc. We've seen looking at production data in order to figure out which actions you can do on the UI and which data is used to do that, and then generate test cases out of that. And we've also seen a lot of cool examples in the past year with large language models actually generating instructions on how to fill out a form and generating test data to fill out that form, and even giving you all of that in Selenium code or Cypress code, etc. So although it does seem tricky, it's actually not that difficult to solve with today's technology. The last bit is the most challenging one. Because how can you expect what the application is supposed to produce? And how can you check that it does provide the proper output across different devices and browsers, right? And do that at a very large scale and without false positives and negatives, right? So that's a very difficult problem to solve. But luckily, at Applitools, we already solved it because this is what we've been doing for 10 years, okay? So putting autonomous aside, what have we been doing with visual AI? Basically, we are providing our customers with an SDK that they can use to augment their existing open source test. In this case, it's an SDK for Cypress, but we support over 50 SDKs that cover all the programming languages, all the test automation frameworks, all the UI technologies from web to mobile to desktop application, testing PDF documents, everything that has a UI can be checked that way. Now, using the SDK, you can add what we call visual validations or visual checkpoints. In this case, it's eyes check window. And what this line of code does when it executes is that the SDK grabs a full page screenshot of the application under test, the current state of this application. and it compares it with the baseline image that defines the expected appearance of the application at this point. If there are no differences, the test continues and passes. If there are any differences that are visible to the human eye, then the test will fail, and the error failure message will contain a link to our dashboard where you can clearly see the baseline image or the expected output on the left-hand side, the checkpoint image on the right-hand side, and the differences clearly highlighted in pink. Now you can see very clearly that in this case, the forgot password link disappeared. Okay, this is the baseline image, it exists. In the checkpoint image, it does not exist. Now, two things that are quite obvious. We are not necessarily developers. We don't know how to read log files, but it's very easy to understand what happened. We have an image of what's expected. We have an image of what we see now. So everyone that knows the product can figure out what changed, and he can even figure out if it's okay or not, because he's involved in the development cycle. He knows if we were supposed to remove that this forgot password link or not, right? The other thing you can appreciate is the level of coverage that we got for this single line of code. It actually covered the entire login page, and it can contain hundreds of elements. And any difference that the end user will see, and any unexpected issue that may pop up, our automation will capture that. Now, not only do we get much more coverage, and everyone on the team, even if he's not a developer, can understand the test results, it's very easy to maintain the tests, because if this is a valid change, all we need to do is just click on the accept button, and this will cause the checkpoint image to be saved as a baseline image for subsequent test runs. If, on the other hand, this is a bug, we'll just reject it and report a bug directly from within the app, and then we can start collaborating with our team members and ask them to fix it and ask what happened and is this on purpose, and we can automatically create a ticket in Jira and other bug trackers to track it there. So a very easy way to allow everyone on the team, even if they are not developers, they can still click an accept and reject button. And even for developers to very easily maintain the test instead of going back to the test code and fixing the test code. So this visual AI technology has huge advantages over the traditional approach. First of all, it allows you to get a lot more out of your existing tests. And by replacing the traditional assertions with those visual assertions, you can actually reduce the amount of test code by 80%. This is a staggering number. It means 80% less code to author when you're creating a new test, but more importantly, it's 80% less code to maintain for the entire lifetime of the test. Each of these lines of code gives you complete visual and functional coverage for the page, which is equivalent to writing hundreds of lines of code in each step of your test. No one can afford to even start doing it or maintaining such a thing. Moreover, this line of code works for any device or browser or form factor that you're running the test on. You don't need to change it, unlike code. Okay, so you're covered across any execution environment without having to change anything in the code. This is the only type of automation that can actually catch unexpected defects. And this was very important for us when we talked about autonomous testing. It does not break when the UI changes, which means that you will never need a developer to go back and fix that line of code once it's there. And the fact that no coding skills required to maintain the validation logic means that everyone on the team can participate with maintaining the automated tests, whether they are developers or not. And all these things together actually lift that glass ceiling where people get to 70% of their time maintaining tests. They can actually automate at very large scale with very little maintenance overhead. This is how Applitools is used today and how our customers are using it. But for the purpose of autonomous testing, this is the main missing ingredient, okay? Visual AI actually eliminates the validation code, which is the hardest part to do. And it is also able to catch those unexpected defects, which really skyrockets the coverage that we're getting and enables the whole thing. So now that we understand that autonomous testing, I hope that I convinced you, is doable, Okay, let's talk about the Applitools intelligent testing platform. So as I explained in the beginning of the talk, we have been spending the last few years actually building out a cutting-edge test automation platform that provides you with premium solutions to all your testing needs. Sure, you can still use all the SDKs, the 50 plus SDKs that we have to add visual validation to your existing tests, but you can also use our test infrastructure, and we've added a lot of options for you for non-developers to actually author complete test suites without writing a line of code. We have a new product Preflight that I mentioned before, and we also have Autonomous that we'll talk a lot about later in the talk. So if we and the Applitools intelligent testing platform actually employs AI in each of its components, whether you're authoring tests, validating outputs, whether you're executing tests, or whether you're using the dashboard to analyze test results. So when it comes to authoring, with Autonomous, we've added the ability to automatically discover new, missing, faulty, or change pages and component on your website or web or multi-page web application on every run. You don't need to change anything as your application changes. You don't need to change any of your tests. We have an NLP builder that basically allows you to describe complex custom end-to-end flows using nothing more than plain English. That's right. You can describe interactions with UI. Preflight, as I mentioned, a company that we acquired, provides a best-in-class UI recorder that allows you to record live interaction with an application and basically record very complex end-to-end scenarios without coding at all. And of course, we have our SDKs that allow you to add everything that we do to your open source framework and stack. We talked about visual AI. The only thing I want to add is that you can use it to test very dynamic websites. You can use it to test applications that change very frequently without having to rewrite and maintain the test code. It's a very mature offering. It supports everything you need to deal with dynamic data, from A/B testing to automatically detecting dynamic regions. It's all there. And you can use it to test any UI, no matter where it's running. So you can use the platform to execute tests on our devices and browsers, but you can also use the technology to validate UI on tests running on-premise, on native devices, desktop applications. It can run on a third-party, with a third-party lab provider. We have streaming providers testing video playback on television sets. We have healthcare companies testing X-ray machines. Okay, so everything that has a UI can be tested with this technology. When it comes to execution, we have the best-in-class infrastructure, and you can increase release velocity with much faster and more resilient builds. You can run tests on scale on our infrastructure. You can run it across different devices and browsers. And a bonus that all the tests that you run there without changing a line of code automatically get self-healing treatment, meaning that the infrastructure itself automatically heals element locators that are broken following UI changes and would otherwise break your test if it was running anywhere else. Okay, so even in the execution part, we have AI that is working for you. We have very comprehensive dashboards in the platform for the different products that give you, on one hand, very comprehensive reports on your build and insights on the historical usage of your test, but on the other hand, the ability to filter and drill down and get all the details for each individual test run. We have root cause analysis technology that not only shows you what changed in the UI, but on a single click also shows you the code changes that cause these changes. So that can save hours for developers trying to figure out by themselves or reproduce problems that are hard to reproduce to understand what caused those. And we also have a very large set of what we call automated test maintenance features, where it is yet another application of AI that is meant to avoid repetitive test maintenance activities. It allows you to group together similar UI changes and issues, so you accelerate the time it takes you to review test results. Okay, very extremely important when we are talking about very large-scale automation that produces a lot of results. All the products on our platform can integrate with everything, with just about any tool in the DevOps tool chain, from collaboration tools like Slack and Teams, bug tracking tools like Jira and Rally, all the CI/CD frameworks, all the major source control management tools like GitHub, GitLab, Bitbucket, Azure DevOps, in the cloud, on-premise, we support it all. And every piece of data that is available in the dashboard, every piece of action that you can do through the dashboard is available to you through an API, so you can basically build whatever type of integration that you would like to have between our products and our platform and any internal tools and custom workflows that you have in place. Okay, so we're done with the platform, and we've reached the main product, the new product, the latest and greatest addition to our platform, which is Autonomous. Autonomous is the world's first fully autonomous testing product for websites and multi-page web application. It is intended to be able to create, with a single click out of the box, an entire self-adjusting test suite for a standard website, getting you anywhere between 80 to 100% out of the box of coverage. And if you have some specific things on the website, specific flows, specific business logic that is non-standard, you can still cover it with custom flows that you can specify in plain English, just like you would explain them to a manual tester to carry out. Okay, this is Autonomous. Now, quickly before we jump into a demo, this is the last slide. It allows you to get set up with a single click. All you need to do is just point Autonomous at your website, provide the URL, and you're done. Everything you need is available out of the box. You don't need there's no third-party dependencies. You don't need a DevOps guy to set up CI/CD. You don't need a third-party lab provider. Everything is working out of the box on top of the Applitools intelligent testing platform. Autonomous automatically creates a self-adjusting test suite that can detect new pages, missing pages, change pages, broken pages on every run. Okay, so even when your website changes, you don't need to do anything. The test suite self-adjusts. Of course, it informs you of any findings, so you can understand if it's okay or not okay, a bug or something intentional. But you don't need to go back and fix any tests. It has the natural end-to-end without doing anything than just writing plain English. You don't need any coding skills. You don't even need to know how to specify strong element locators. You just don't need it. You can use that, but you don't have to use it. Everything is running on our best-in-class test infrastructure, so you can execute your test at vast scales across different devices and browsers out of the box. You can launch the autonomous tests and orchestrate them in a very flexible, with a lot of flexibility. You can run the tests on demand. You can run them from your external CI/CD using a webhook, or just use a built-in test scheduler. So you actually don't need an external CI to do that. You don't need any DevOps skills to configure it. It's pretty easy and happens automatically. And we also use the same seasoned, let's say, or perfected automated maintenance functionality that we have had in ICE for years, and the self-healing functionality that we have in the execution cloud infrastructure. And basically, it really allows you to scale your automated tests, to scale your coverage, without really increasing the amount of test maintenance that you need to do in reviewing and correcting the test results. So enough with the slides. Let's see Autonomous in action. So here is Autonomous. Very nice to meet you. And we are standing on the tests panel now, where we can create new tests. And basically, this is version 1. We have 3 ways to author tests. In the future, there will be more. The first one is, if you know what are the top pages on your website or multi-page web application, and you want to focus your test there and only there, you can just create a URL list, import it from a file, and just create a URL list test, and Autonomous will just periodically, per the cadence that you decide and dictate to him, will monitor those pages and inform you of any changes that take place there, and you're done. If you want to test some custom logic, whatever logic it is that you want to test, some business logic that is specific to your application, you can create a custom flow. You can create a custom flow in plain English, and the AI will execute it. No code at all, no element locators required. We will soon see that in action. But what we really want you to do is to let Autonomous create a full website test for your website, and this is why this is the big button here. Let's click it. And we can see that all we need to do is just enter the URL for our website. So the purpose of this demo, we'll just use this very plain demo website that has 5 URLs. We have a homepage, some simple form. We have one page that requires credentials to see. Okay, the basic auth one, just a minute. Here it is. So I have to get to provide credentials to see it. Let's go back. And we'll just take this URL and provide it to Autonomous. When we are setting up the test suite, we have 3 execution environments to begin with. Of course, we can add more later. There is Edge on Windows, we have Safari on Mac, and we have Chrome on Linux. I can disable the ones that I don't want, but let's run on all of them, and we will click Next. What's happening now is that Autonomous is scanning, is reaching out to this website, scanning, exploring it, finding out all the pages. Here we can see that it found that there are 5 URLs, and he wants to test them across 3 different execution environments, the ones that were chosen in the beginning. Now, it goes to these URLs. If any of them are broken, inaccessible, timing out, crashing, any type of error, it will highlight that as a problem on those pages. All the pages that are accessible to the end user, it automatically creates baseline images for them, just like we saw when we described how visual AI works. And this means that basically we freeze their current state, and any deviation from that current state, whether because a developer pushed new code that changed it, or because we depend on a third-party service that provides us data and it will have a malfunction or return different data, or whether because we just upgraded the browser to a new version and it created a problem on our website, even though we didn't change anything, all of these things, any unexpected difference that would happen, you will know about it. So we are done with the setup phase. We can see that we found those 5 URLs. We have thumbnail images here that show us the pages. We see that we have one issue. We can see that it found that the basic auth page is inaccessible, and that makes sense because we need to provide credentials to get to it. Now, of course, you can provide those credentials either via basic authentication or by defining a custom flow that will occur before the exploration, so you can just do whatever it is you want to authenticate before reaching out to the website. But you can see an inaccessible page that was reported. On top of that, our test suite now is scheduled to run every day at 8:30 a.m. A plan was created. A plan determines a set of tests and the schedule to run them, and the environments, the execution environments to run them on. And it is already set for us. So without needing any DevOps skills, no need to write a line of code, no need to do anything. We already have a test suite that is up and running and ready to go. Now, we won't wait until tomorrow. Let's just run it now. And this would be our first run against this baseline. Now, every time these tests run, every single time, the whole process repeats. Autonomous goes to the website, starts scanning it from fresh, finding whatever pages it can find. If there are new pages that were added since the last run, it will let you know about it. If there are missing pages that were removed, it will let you know that there is an issue there, that it is missing. And of course, all the pages that are there are compared with their respective baselines. So if anything changes, as I explained before, you will know about it. So just think about the tremendous level of coverage that you're getting. If this is a completely static website, you're getting 100% coverage of everything that you need. Okay, everything is loading, everything looks exactly as you expect it to look like across any number of devices and browsers. It is not timing out, it is not failing, everything is intact, okay? Amazing result for doing nothing, okay? Now, the test first run ended, we have the same 5 URLs across 3 environments, we have 15 screens in total, we have the same issue as before, we didn't change anything here, so that's expected, and we can go ahead to view the results. Looking at the results, we would see that we have 15 screens in total, 12 of them are green. Why are they green? Because each of them has a checkpoint image compared with the baseline image. They are matching, so there are no differences found, and we are good. On the other hand, we have 3 screens that failed, those that had the basic authentication issue. Now we can see here that they don't have a UI because they didn't show one. If there was a custom access denied page, it would go here and be baseline. But we can see that there is an issue that the URL cannot be reached. I can, of course, decide to accept this as proper behavior. I can change the plane to provide credentials so I can get to those pages. I can decide to do whatever I want. I can also decide to exclude folders from the search, exclude specific URLs. I can just focus on whatever it is I want to do. Now, there are forms on this page. For example, this simple form over here, okay? And what I can see is that in this form, I can enter an email and click submit. And this is functionality that I want to test. But AI couldn't do that for me out of the box. It won't fill out custom forms for me because it has no idea how to do it. So this is where custom flows come into play. What I can do is just, on top of this form, I can just ask to create a new test starting here. And a new test is created that starts by navigating to this form, and I can easily execute it on our platform. So I don't need to install anything. I don't need anything, just like before. I can run and see what we get. So we got this page. I know that I need to put in the email address and click a submit button, and I can do just that in plain English. I can just say, okay, enter Adam Carmi at Applitools.com as email, and I can click the submit button, and I can add a visual validation point, and I can run this thing and see what we get. Very easy, very simple, trivial to do. Fantastic. If we look at the click here and we zoom in, we can see that now we have Adam Carmi at Applitools.com filled in as the email address, and the submit button is clicked. And we can also see not the outcome of the action, but the action itself. And if we zoom in now, we can see that actually the correct submit button was clicked. I can verify that. Now, this is what we call prompt-based testing. And it's extremely efficient and effective way to author tests. First of all, everyone that knows how to test can produce these tests. Second, it is very readable and easy to maintain. Third, I don't need to use any element locators. Of course, I can say click the button with the CSS selector and provide it. It will still work, but there's no need to do it. I don't need the skill set to get it. And it's actually an advantage not to use it, because if I'm not using the element locator, I'm letting the AI find the element for me, and it does a very good job at that. And even when the implementation changes, the test will not break. Another advantage of this approach compared to record and playback tools is that a record playback tool works fine until it doesn't work. If the tool makes a mistake and you recorded something that it failed to record correctly, you're stuck. There's not much you can do as let's say, a non-developer to work around that problem. But here, you can just use English to be more specific in disambiguating the element that you want to work with. And this is something that each and every one of us can do. Okay? Now, I want to show you a bit more of prompt-based testing, and we're running out of time. But quickly, I want to show you how we can parameterize this test and do data-driven testing. So I can actually, maybe I want to try out different emails. So I can very easily just go in and replace this concrete email with a parameter. And I can just call it email. Okay, and now I can save my test. Let's call it fill out the form. And I can create it. And now under test data, I can see that I have a new email parameter. It shows me all the tests that use this parameter, and it shows me all the data sets, or the data sets that you would normally use for data-driven testing that actually provide values for these parameters to simplify attaching the test to those data sets, which will cause it to run for each row in the data set. So it's very, very easy to specify parameters, to pass parameters between tests, to associate tests with data sets, or just reuse tests with different parameters, just like you do with code. So that's trivial. So I want to show you a little bit more about prompt-based testing, and I want it to be a bit more interactive, so I'll use this tool over here, which we call the NLP Playground. And we have here a prompt on the left-hand side and a browser on the right-hand side that this prompt controls. So let's spend 2 minutes driving Wikipedia just to see how effective it is. So let's start with something simple. Let's click the English link. So we can just say, click English. And here we are. We can go back. Let's try to click this Russian link over here. We can say, click the link to the right of English. I don't have Russian fonts, but I can get to it this way. I can go back. Let's try this Française link over here. We can say, click the second link below the link to the right of English. And here we go. We can search Wikipedia. I can type functional testing in the search box and hit enter. And here we are on the functional testing page. I can try to click this show link here to the right of tools. That would be a bit cumbersome to do with code because I'll have to find a container for all these links and then enumerate them and click the sixth one, but then it will be a flaky test because if someone adds or removes a link above tools, it will fail, it will click the wrong one. But with prompt-based testing, I can just say, click show to the right of tools, and AI will take care of the rest. I have a bunch of edit links. I want to click this specific one next to 6 steps. I can just say, click edit near 6 steps. And I can go on and continue and automate whatever it is that I want to do in a very intuitive way. Almost every bit of AI technology has to be used to get and implement what you just saw at the level of accuracy it performs. Visually, emulating the human vision is a huge problem to solve. And to do that, we need to figure out how to solve dozens of problems and challenges, including a lot of rule-based algorithms and deep neural networks to model color perception, distinguishing between text and images, pictures versus graphics, detect dynamic patterns on the pages, etc. Automated test maintenance requires finding similar differences across operating systems and different fonts, self-healing element locators. We need to be able to find elements with broken locators based on previous successful test runs, which requires many algorithms and machine learning models. Pre-flight can automatically generate test data. It uses the deep neural networks to understand screens, to understand forms, understand fields in those forms, and correctly infer their types so it can generate the proper data for them. And of course, Autonomous is heavily using generative AI and large language models in order to get all that coverage for you and to understand so well that English instructions that you can provide it with. So the reason we call our testing platform the intelligent testing platform, because it is the world's most intelligent testing platform, and it does apply AI in each and every one of its components. So with this, I conclude the session.
We'll go through a few questions that were asked. We had a ton of engagement from the audience, and then I do want to close with just one last thing at the end. So, okay. Let's see. How does the self-healing work with object locators?
Yeah, so the way that it works is that every time, so first of all, every test that you have, every step of the test interacts with an element, right? You find an element to click it or to type text or to query its properties and assert on them. So every step queries for an element. So when you're running your tests and you run it on the Applitools infrastructure, it actually finds the element, but before returning it to your test, it actually learns everything about it. It collects hundreds of data points about that element and all its properties, its neighbors, parents, ancestors, everything that it needs to find that element in the future. And every time you find the element, it relearns everything about it. Now the day comes, the UI changed, you try to use the locator is broken. We cannot find the element. Instead of simply returning an error to your test that would cause it to fail, we actually now go to our databases with that element locator and find the wealth of information that we know about that element from the last time we found it. And then we run proprietary algorithms to actually find it in real time on the page, just like a developer would do to fix the code. And we return it to your test. And we also relearn everything about it now that it's changed and save it in the database again, stored under the same broken locator that you're constantly using. So as far as your test is concerned, the element was found, the test is passing. In our dashboard, we are showing you that we have healed that element and even suggesting an alternative element that you can use to correct your test, although you don't need to do it because you can just keep using that old locator. We will keep finding the element for you and keep updating our database as it changes over time. So it's a fantastic technology. It can save up to 50% of every test automation developer on your team if you're the type of team that struggles with flaky tests due to element locators or having like a tough time testing an untestable application, or if you have juniors on your team that don't know how to use proper locators, it's enough for them to get it right once and then self-healing will take place. So it's an extremely powerful technology. Next question.
Okay, great. How does Autonomous deal with tests that are dependent upon data being input?
Yep, so as I showed, you can basically parameterize any of the tests. You can then use data sets to drive your test or just reuse tests providing specific data points in the plan itself on how you want to activate them. And you can place assertion based on that data, and also the baselines themselves that are created take the values of the parameters into account. So if you have a test that has a visual checkpoint and you run it 5 times with different values for the parameters, it's not that the same, you'll get differences because you had different values. There will be different baselines for each of the values. So it will be work just as you expected.
If the dev changes the element locator, will that break the custom flow test? What do you think, Moshe?
No, it's a great question. No, so actually it won't break the custom flow, and you can actually even change the entire underlying implementation. So even if someone would change from Angular to React, as long as the logic of the application stays the same, the description will still work. I mean, you basically describe the test as go to the first name field and enter Dave and click the submit button. So again, as long as there is a first name field and as long as there is a submit button, the underlying implementation doesn't really matter. And this is actually very powerful because when you think about how automation testing is done today with code-based tools like Selenium, Cypress, and others, or with codeless tools, again, like all the codeless tools that are out there, it's always still dependent on the underlying implementation, the selectors, the IDs of the element. And here you basically decouple the implementation code from the test code, which is really powerful.
Great. That's a great response. Next question. Is it possible to use autonomous on internal applications?
Is it possible?
Well, I think it is.
No, just kidding.
I hope it is.
Yeah, it is possible. So we actually have a tunnel, kind of like VPN-like solution, which allows you to run the test on internal applications. So even if you test an application behind a firewall that's only accessible from inside your network, you just need to configure this tunnel. It's a simple setting in the autonomous settings, and our team can also help you do that. And once that setting is in place, you can run autonomous on internal applications as well.
Okay. Can autonomous create random data based on the type of it, so I don't have to create mine and test good and bad data?
Who asked the question? Maybe we should hire her as a product manager or her. That's also Alejandro. Yeah, that's great. So yeah, actually, that's an excellent question. So this is it's not available right now, but very soon you will be able to do it. So very soon we will be able to generate test data for you with positive data and negative data. I mean, right now you can parameterize your test and you can import data sets to run your test on different data sets from external files, from external database. So you can import these data sets. But if you would like autonomous to generate test data for you, you will be able to do it in the near future, but you're not in version 1.0.
Okay. I have some Cypress tests that I'm running. Can this replace my Cypress tests?
Yeah, so that's more kind of like a philosophical question, I guess. But and then we can also hear your opinion. But generally speaking, what I usually tell people when they ask me this type of question is like, I mean, if you have your Cypress test and you have people in the team that have the skills to write these Cypress tests and are happy writing these tests, and you feel these tests are stable and are working well for you, I wouldn't replace these tests. I mean, what's already in place, I mean, keep using it and keep enjoying the benefits. If you have a new project or if you need to create some new tests, I mean, there are definitely benefits doing that with autonomous. I mean, it's faster, it takes less time to write and maintain these tests. And also people in the team which don't necessarily have Cypress authoring skills can do that as well. But again, if you have people in the team that are already building Cypress and Cypress is working for you, you can run Applitools with Cypress. You can execute the test. So we can help you with all the other things without autonomous on top of Cypress still. And anytime you have a new project or anytime you want to build some new tests, you can do it with autonomous.
Yeah, I mean, I'll just add to that. It's a question of value. And Adam alluded to this towards the beginning of this talk about, and he didn't quite say it in these words, but I think to paraphrase is basically software testing is a practice of trade-offs. You never have enough time to do everything. And it's about what can you do with what you have today and how can you get the most value. And then from there, I think making your decision. So if you're getting value out of something you already have today, there's no reason to replace it. I think, though, it's a question of like, are there opportunities to augment what you're doing, or are there new opportunities to bring in tooling that can make you more efficient? I think maybe at some point, if you find more value out of a different tool, then potentially it could replace what's existing today, because it could change fundamentally the process and people that are involved in like the things that they need to focus on. And just to go back really briefly to Alejandro's question about the data, and you mentioned how there's things coming that don't exist yet today. I think it is worth mentioning and pointing out that what we have today and what we're highlighting today and showcasing today is actually a great milestone for us to share with everybody. But it's just one step on a much larger journey to go on. Because I feel like what we at Applitools are doing is we're building the future of testing. And so I think that it's kind of a yes and. It's like, yes, we will offer that, and we're going to just wait, like, because 6 months from now it's going to be fascinatingly more sophisticated and have far more functionality that you didn't even think needed to exist, and it's going to be great. So it's like it's really good today, and it's going to keep getting better, and we're going to keep building the future of testing. We're not going to stop. And so that's, just wanted to call that out. Okay, next question. How does Applitools integrate with existing Java WebDriver tests?
Yeah, so that's a good question. I mean, it's not so much related to the autonomous testing part, but we have SDKs for Selenium, which allows you to integrate your Selenium test with Applitools, and then you can enjoy all the visual AI capabilities that Adam mentioned at the beginning of the talk. So that's really easy. I mean, it's like a line of code that you add at the beginning of your tests, and you can get visual AI capabilities running on top of your Selenium tests. And we have tutorials on the website for Selenium. We can ping who asked this question offline and share these links.
And actually, I'll add to that. It's not just the visual AI. I mean, Ultrafast Grid is, to me, one of the lesser known, most impressive and innovative pieces of tech that we've built that I think is slowly taking the industry by storm. Hopefully, with autonomous, it makes it even more approachable for people. But the fact that it completely transforms the way the people normally run their tests. Instead of it being a one-to-one transaction between every test and every flow for every app page on an app, it's like we invert it. You don't have to run 50 browsers to exercise all the different combinations for one specific case. It's like we just do it once, and then we handle the concurrency on our side. We just invert the model, adds so much more stability, as it makes it so you can scale horizontally. And I think with the commoditization we're seeing for CI providers, how affordable it is within like GitHub, Circle CI, and et cetera, to get access to really cost-effective machines and browsers, we're starting to see a lot of companies actually not need traditional grid providers. And especially by using Ultrafast Grid as kind of a replacement plus something like a CI provider. So I think that's such a powerful combination. So that's just something that I'll also add. And then I think we have time for one more.
That's a great point, David. I think we have Mike Milgate in the audience here. Maybe we can bring him to a webinar to discuss that.
I think we should. I think it's a topic no one's talking about that we really should bring to light. Okay, last question. Is there a specific key dictionary that one must learn to help the NLP perform better?
So I think that the beautiful thing here is that you don't really need to learn any like a new language or unique like keys or anything like that. I mean, you just write your test really like in plain English, and you also have like autocomplete that completes the commands for you. So it makes it like really easy to write tests, and we constantly improve the NLP library and the engine itself. So it just gets smarter and smarter. And again, like in the very near future, you'll just be able to paste your documentation or just paste your user stories, and it will just translate it to this language and create the test for you. So there's some really exciting things happening in our lab right now. And again, I can't wait to show you all these things as we're launching it gradually.
That's it. Thanks, everybody. We did it. Welcome to the future. It's now.
Thank you, everyone.